Hello, this is your favorite Codesys influencer talking again. So in this video, we'll be exploring how to do reading and writing of modbus register to the same register. Okay, so without further ado, firstly we will start off with calling off using a software called modbus slave so that my PC can act as a modbus slave, obviously. Okay, so I configure it to be modbus TCP using this specific Ethernet port on my PC. Okay, so you can see I have already set it up over here, and after that, on my end, okay, I'm using a TX700S from Turk as my PLC modbus master. Okay, so over here, let me configure the Ethernet port. Okay, and then over here my modbus TCP master, I'm going to change the version, okay, to the version that I think most of my interested viewers might be using. Okay, so over here I can choose the version, and then now I'm gonna scan for my device. Okay, yes, okay, my device is connected. Okay, and I'll choose the Ethernet port that I'm using. Okay, and then I will choose to auto reconnect if there's any disconnection, so it can save me some effort. And I need to configure the IP address of the slave, which is my PC. Okay, so once this is done, I want to remind you that our goal is to read and write to the same register. So let me add a channel, and for reading and writing, if I bring it down, hey look, there is a read write multiple register over here, and I'm going to use this. Okay, so I'm going to go to the same register with lang 1 and over here, and I have successfully declared it. Go to mapping, and you can see the registers over here. Okay, sorry, I'm going to name it read, and I'm going to name it write. Okay, so now over here I'm going to instantiate it in my main program. Okay, so compile, bring it in, and go. Oh look, the value is not here. Not very convenient, is it? Let me bring out the array value. Let me try again. Okay, sorry for the extra time. Okay, now there is some value. Okay, it's a lot easier. So over here you can see that I have successfully connected to my PC over here, and let's just say for here. Okay, wait, before I do this, okay, we're gonna see this is my modbus slave. Over here I'm reading, this is the value 0, I'm reading 0. So let's just say that I want to write a new value in. Okay, for example 50, push it in, and okay, so I've successfully wrote the value 50 into my modbus slave, and after that I'm reading it back, okay, on the same register as 50. So let's just say I try to change the value on the slave side to 123. Oh no, something is happening. Something is preventing me. The value doesn't change. Is my program the problem? No, I can happily change the value on other registers. So what is happening? So the minute I'm actually attempting to change this value, okay, 123, I'll go back to this program. Okay, I changed it for maybe a few milliseconds before this, my PLC forcibly write it back to 50. Then, oh no, how can I have a responsive system where my PLC communicate with the slave, and the slave can feedback back to the master on the same register? This is not exactly very useful, is it? Huh? Okay, one alternative is to declare two different registers and read and write from there. But then what if sometimes you are using the same register? What can you do? Huh? Okay, so in this case, what I want to do is we're going to use this command that allows me to more flexibility to control specifically when I do the writing. So I may read it many times, but I will only write it one time when there is a change. Okay, so in this case, let me go to this function, delete it, add a channel. I will separately read and write the register. 1. And for writing, I can go write single register, and instead of cyclic, I will do it only on the rising edge. Okay? Ta-da! Okay, so now if I go to the mapping, you'll see that I have a reading point, I have a same writing register, and now I have a trigger variable. Okay, so using the same name, can declare it, and I will have an extra variable called start. Okay, so now if start, then I will change my write register value to 1. Simple as that. Okay, now let me instantiate it in. Okay, now if I run it, you can see that okay, I'm reading the previous value of 50 over here. So let's just say that I should not have. Let's just say that I want to change it to 1. Okay, this code over here forcibly change it to 1. So let me put over here, and you can see when I change it to true, the whole thing turns to 1. Okay, and my read goes to 1. But I will also have the option of changing the actual value from my slave side. Okay, let's just say I process, I like 1. I'll do my own processing and I update my own value. Now my PLC is able to receive the correct value as well, the processed value over here on the same register, saving 1 register space. And let's just say if I just want to write again, I can still overwrite it as and when I want. So there is a lot more control over when you want to read and when you want to write. Okay, using rising edge. So what is the application? Is there even used to using the rising edge? Why not just read it all the time? Well, in this case, I'm actually using a banner, a new device over here, my banner DXMR90. You can see on my camera, okay, which is loaded with a vibration monitoring script. And in this case, there is actually it's continuously checking for the connection status of my vibration sensor. Okay, so I'm able to check for the register status of the vibration sensor over on the local register over here, and if any of them disconnect, in the case where any of them disconnect, I am supposed to send a data 1 into register 832 and wait for it to change to 0. Okay, so 832 will trigger the microcontroller to start rediscovering if there's any disconnection or connection, the newest connection status of its own sensor. Okay, so in this case, my slave itself limits me to reading and writing to the same register, which, like in many cases, you don't have much of a choice on how the slave operates. Okay, so let me adapt this project into the use case over here. Okay, so let me turn off this thing, and then I'm gonna reconnect this guy to a new slave over here, and you notice I cannot change anything, so until I refreshed it again. So my slave is actually using this IP address, and I'm actually reading and writing to offset 231. Okay, so just a friendly reminder, some devices actually start off counting the modbus register from 1, and some devices start off from 0. So Codesys PLC will start from 0, well, in my case, this banner DXMR is actually starting from 1. So instead of checking 832, I need to check 831 by -1. Okay? Yeah, it's okay. But if you're not using the same device, you can just ignore it. Okay, so over here, let me change it to 831 as well, reading and writing to that one register. And just for the sake of complete checking, I'm going to check. Okay, maybe the status of the connected sensors. Okay, so now over here, let me give it a name, status. Okay, over here, status 0. Okay, 1, 2, 3, and 4. Okay, so now here I go. Over here, let me log on to the device itself. Okay, and run, and I am connected to the sensor itself. Okay, and you can see over here, okay, if you have time to study the datasheet of the banner device, you'll see that the status of any connected sensor is 128. So let's just say that I have another sensor, sensor 1, that is not connected, so it's 0. So let's just say that I connect it back. Okay, once I connect it back, okay, once I connect a new sensor, I will need to inform the controller that there has been a change, and I want the sensor to discover the new device. Okay, so, and according to the datasheet, I need to send a 1 to the sensor discovery, and then wait for it to change to 0 when complete. Okay, so in my case, so this is why I have it over here, start. Ding. I change it to start, and it wrote 1 into register. Okay, you can see this was 1 for a while before it changed back to 0, which is completed. Once it's completed, my status is updated over here. Voila, done. Okay, so you can end the video over here if you're just interested in this. So now you have a problem. My start bit is not on true. So how can I reset this? Okay, do I need to come back and always come back to the Codesys program to change it to 0? Of course not. Why the hell should I do that? I must remember to make it to false. Okay, so let's go. Da 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 da. Hey hey. So let me plug the sensor. Okay, and readjust the sensor status. Okay, so I want it to update and check and make sure to update the status that it turns to 0, because I have already unplugged my sensor. Okay, so now let me do the same thing. Right, to start trigger the register to write 1 into the modbus register. Okay, wait, did it turn to 1? No. Something is wrong. Something is wrong. Oh, well, if you have already noticed, this thing is not exactly working. Oh, but it changed back to 0 by itself. Okay, I guess the device is quite smart. But anyway, so now I want to connect it back. Okay, just to show that it's not exactly working, I will connect it back so that we can have the same experiment just now. Okay, nothing is changing. Just now you saw that when I trigger a start bit, this thing remained 1 for a while before this turned back to 128. But over here, nothing is happening. Why? That is because the minute I turn start on, it gets turned off. Okay, but isn't this a rising edge? Yeah, shouldn't it be writing this value into the register and triggering the sensor discovery status? Yeah, but here's the problem. After you turn it to true, immediately the next step you turn it back to false. Before it can reach the actual value of the start bit will always be there's only the change is only changing in this part of the program code. Before it can reach into the physical stack and update over here, I have already changed it back to false. So here there is a rising edge, but here there is no rising edge. Okay, so how to make sure it reach a rising edge? There is a rising edge in the physical stack. You must make sure the code run finish all the way to the end, okay, with the updated change before you change it back to false. Okay, so now how do I do that? Okay, so very easily do a verification check that your read and write registers are the same. Only then do you change it to false. Okay, so over here I'm doing a verification check. Okay, only when I read back, I know that the register value has already been changed. Do I stop the trigger and refresh the trigger? Okay, reset the trigger bit. Okay, now let's try it again. Oh, and let me turn it off. Let me run it off. Okay, and run. Da, 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 da. Okay, so now my system has detected that one of my sensor has been disconnected. Okay, so so I'm gonna connect it back, and I'm going to trigger the sensor discovery function. Okay, so turn it to 1 and then turn it back to false. See, here you go, you have successfully wrote a script that allows you to read and write to the same register using the rising trigger application. Okay, and also you also learned how to reset this trigger bit automatically by verifying that the value of the reading and the writing is the same. Okay, to know that your writing has succeeded and before you actually reset the bit. Okay, so that's all. I hope you enjoy this video. Stay awesome.